Good morning, ladies and gentlemen, and welcome back to Miles Maths. Today, we're going to be talking about circle theorems, and we're going to be talking about how to tackle problems with circle theorems and problems with circle theorems that are slightly more difficult, perhaps, and how to approach those problems, how to get into those problems, ways in which you can begin to look at tackling them. So, from the point of view, an exam point of view, the first thing you need to do is learn the circle theorems. These are they from Corbett Maths, which is a fantastic website for this sort of thing. And here's some questions from Dr. Frost. Nick directly out of Dr. Frost. I'm making no bones about it. They're just questions we're going to try. I've blown the diagrams up as big as I can. Now, let's have a look at this diagram then. But before we do, let's read the question. P, Q, R and S are points on a circle, centre C. This is a circle, that is its centre. So immediately we've got the centre of a circle, we've got one of two circle theorems that we're using, this one or this one. So PCR is a straight line. PCR is a straight line. That means it's a diameter. That means we're using this circle theorem. I know that right from the start. So right now I know that this PCR is a straight line. Angle PRS is 36 degrees, shown on the diagram. Calculate RQS. So the first thing I'm going to do is I'm going to work out the angle that I want. It's that one. And I'm going to put a little question mark in it, just so I know what it is. That's the angle I'm finding. Now, I'm going to think about this circle theorem that I already know about. I know I've got a diameter in here. I know I'm using this. So, which two angles, in this case two, are subtended by the diameter? Or are in a semicircle, depends which way you look at it. So this angle here is clearly 90 degrees, and this angle here is clearly 90 degrees. There's the diameter, there's the right angle. So I'm just using the diagram. I'm just going to work my way through this problem to find this angle without writing it down. Then I'm going to write it down. Now I'm going to look at this. I can see that I've got a 36 degree here. If I look at this, I can see that butterfly shape. And if I compare that to Corbett Maths and to their circle theorems, I can see here that here we have 32, 32. So here we must have 36 and 36. And my reason for this is that these are angles in the same segment. So I know that this is going to be 36 degrees. Now that's going to allow me to work out this angle. What I'm now going to do is I'm going to write this down, but I'm going to write this down properly. So I can say, first thing, I need to know that this angle's a right angle. So PQR. So angle PQR equals 90 degrees. Why? Because angle in semicircle. Second thing I worked out that this was 36 degrees. This is angle SQP. Angle SQP equals 36 degrees because I'm going to give a reason. Here's my reason. Angles in the same segment. So angles in same segment. I'm going to write that down. Now I've got to work out the missing angle. The missing angle is RQS. So therefore, angle RQS equals 90 minus 36 equals 54 degrees. Why? Because angles in right angle might have angles in right angle. And that's a good enough explanation. Oh, they've left me a little space here. I'm just going to fill that in as well. Job done. I know that I've got 1, 2, 3 steps, including the answer. So that's three calculations plus an answer mark. Perhaps some of the marks are given for the reasons down here. I actually know from the mark scheme that they're looking for reasons for this for the full marks. So that's how we structure the question. That's how I approached it. I learned the theorems. I had them written down actually. I read the question. I looked for clues. I'd got a diameter. I'm using this one. I've got that butterfly shape. I'm using that one. I drew on the diagram. Then I wrote it all down, showing my reasons. Here's another problem. Question 2. First thing, learn the theorems. There they are. Second thing, read the question. PQRS is a cyclic quadrilateral. Opposite angles in a cyclic quadrilateral. I'm reading the question. Cyclic quad, cyclic quad. I'm using that circle theorem somewhere. QS equals QR. QS equals QR. Oh, look, I've got an isosceles triangle. Right, I'm going to be using that as well. VST is a tangent. A tangent. Okay, let's look down the circle theorems. Which ones involve tangents? This one involves a tangent. Do I have a radius as well? No, I don't. This one involves a tangent. Alternate segment theorem. Do I have a radius in this one? No, I don't. I don't have a radius in either. Do I have a triangle touching the tangent? Oh, look, I do. I'm going to be using alternate segment theorem. So I've learnt the theorems. I've read the question. I've looked for some clues. I know now that I'm using this circle theorem and this circle theorem. I need these two, and I also need the fact that I've got an isosceles triangle in here. And we get stuck in. So my first thing is, okay, this is 2x. Looking at alternate segment theorem. Oh, I've got to work out the value of x, by the way. I should mention, working out the value of x here. Let's just think about how we're going to do this. What I need is so many x equals a number. If I know what this angle is, I know that this angle and this angle add up to 180 because of opposite angles in a cyclic quadrilateral. If I know these two angles add up to 180, then I can find a value for x. I need to know what that value is, what that angle there is. That's all I need to know. So that's how I attack the problem. So let's start off by saying, according to alternate segment theorem, if that was 60, that is 60. So if this is 2x, this is also 2x. I like that very much. I'm going to write that down straight away. So RQS. So angle RQS equals 2x because alt seg theorem. Done. Next, what have I got to use? I've got this isosceles triangle. Now that means that this angle here, marked with a double arc, and this angle here, marked with a double arc, are the same. So if I know this one, I know this one. Fantastic. What do these three angles add up to? Well, they add up to 180 degrees. Perhaps I'm having trouble doing this with some algebra. So perhaps I just do a little sketch in the corner of my page that I'm just going to cross out later. If I had a triangle like this, and I knew this was 40 degrees, how big would these two angles be? Well, if it were 40 degrees, it's not, but what if it were? How big would these two angles be? Well, I can kind of puzzle that out as being 70. How did I do that? Well, I said that each of these angles was 180 minus 40. I took the 40 away from the 180. I got, therefore, these two angles must add up to 140. And then I divided the whole thing by 2. And 180 minus 40 is 140, halved is 70, and I know these two angles are 70. So actually, what I need to do here is I need to do a similar thing. So I can now say that if I want this particular angle, QRS, so angle QRS must be equal to 180, but it isn't minus 40, it's minus 2x, because I've got a 2x, not a 40, divided by 2. Well, if I divide the whole thing by 2, 180 divided by 2 is 90. So I can say this is 90. 2x divided by 2 is x. So each of these angles is 90 minus x. And I can write that on my diagram. That's great. 90 minus x. Doesn't matter about the colours. Why is this true? Because isosceles triangle. Okay, Good. Got my second thing done. This is 4 marks. I've got 2 things done. These 2 angles I now must add up to 180. So I can write 7x plus 90 minus x must equal 180. Why? Because this was the circle theorem I was going to use for this. Cyclic quad. So I'll put opposite angle z, cyclic quad. Oops. And now I can just do this calculation and go and get a value for x. 7x minus x is 6x. So I've got 6x plus 90. Do one step at a time. I'm going to take 90 off both sides at this point. I'm going to use different colours for that to make it obvious what I'm doing. So 6x equals 90. And 90 divided by 6, well, x must be 15 degrees. So I'm going to fill the answer box in 15 degrees. Let's look at what I did. I learnt the circle theorems. I knew what I was doing. I've got them written down, but you've got to learn them for exam purposes. I read the question very carefully. I looked for clues in the question to which circle theorems I was going to use. I drew on the diagram as I went along, and I wrote it all down properly, giving reasons for everything I was doing. That is how you get full marks. Let's take another question. The diagram shows a cyclic quadrilateral, ABCD, ABCD. Oh, I'm going to be using this one again then. ADE is a straight line. ADE is a straight line. What does that tell me? Well, it doesn't tell me anything. It's not going through the centre of the circle, so it's not a diameter, but it does tell me some other stuff. It tells me that these 3 angles add up to 180 degrees because angles on a straight line add up to 180 degrees, and I know that. CE is a tangent to the circle. CE is a tangent to the circle. Fantastic. Okay, so I know this is a tangent. That's good. Therefore, let's look at the theorems that use tangents. Do I have a radius as well? No, I don't have a radius. I'm not using that one, therefore. Do I have 2 tangents? No, I don't. So I'm not using that one either. So I'm using alternate segment theorem again. I must be. So let's have a look at this third problem. Where can I start? Well, I know that 37 plus 46, 37 plus 46 is 83. Good. 83 degrees. This angle here and this angle here must add up to the same thing. That must be worth a mark. So I'll get stuck in and do that. I'll draw on my diagram. I'm going to work that angle out. That's great. So angle ADE must be equal to 180 minus these 2 angles, because these 2 angles and this angle have to add up to 180. So 37 plus 46. We actually know that's 83. 180 take off 83 is 97 degrees. Why? I need a reason. Because opposite angles, cyclic quad. Do you notice I'm not doing anything different every time? I'm taking these things kind of the same approach every single time. I'm now going to write that on the diagram. This is 97 degrees. I need this value x here. This angle here, well, these 2 angles must add up to 180 degrees as well. So I can say, therefore, CDE must be equal to 180 minus 97 degrees, and that must be equal to 83 degrees. Why? Because angles on straight line. You can write supplementary angles if you'd rather. It would still be technically correct. So this is 83. So now all I need to know is this angle here. This angle presents a little bit more of a problem, can I say? So I want this angle. Let me think. I want this angle. What other angles in this shape are the same as this angle? Well, I can see from alternate segment theorem down here that this angle, if I have a triangle here, is equal to that angle. There's the triangle. So this angle and this angle are the same. Doesn't help me. I don't know what that angle is. Ah, but here's this butterfly shape again from angles in the same segment. So this angle and this angle are the same. Fantastic. Now I've got to write that down. So I know that this is 46 and I know that that is 46. Fantastic. But I must write it all down. So, therefore, angle. I'm going to write this one down first. CAD. CAD equals 46 degrees because angles in same segment. I'm going to write that down. Brilliant. Next, I need to write that this angle is the same as this angle. So, angle CAD equals angle DCE equals 46 degrees because alternate segment theorem. So I can write these on my diagram. That's 46. That's also 46. Doesn't look it, but it is apparently. Now I know that these two angles add up to, these three angles add up to 180 degrees. So I can say, therefore, x must be equal to 180 minus 83 plus 46 equals, calculator, I've already got 83 in there, I think. 83 plus 46 is 129. And I want to take that away from 180, so 180 minus answer gives me 51 degrees. So x is 51 degrees. Done. What did I do? I learnt the theorems, I read the questions, I looked for clues, I drew on the diagram, I wrote it down properly, giving my reasons. And what we're going to do is we're going to call this part 1, and we're going to call it there for today. This is Mr. Miles signing off. Summary of what we've done today. Learn your theorems, read the question, look for clues, draw on the diagram, write it down properly, giving reasons. That is how you solve circle theorems.